All right, today we're going to continue our unit on circles, and we are going to focus on the tangent of a circle. So let's look over some of the vocabulary. It says that a tangent, this is a line in the plane of a circle that intersects the circle at exactly one point. So this is a line that's going to touch the circle in exactly one point. That point of intersection is called the point of tangency. So this is what we have. If we have a circle and we have a line that's in the same plane as that circle, and if this line comes and gets ever so close, it will touch this circle in exactly one point at A, and then it continues on. This line is the tangent line. This is the point of tangency. Okay, with that being said, we have a theorem, and that is, if a line is tangent to a circle, then it is perpendicular to the radius drawn to that point of tangency. So what that means is if I have this circle and we say line L is tangent to circle S, T is our point of tangency. When we draw a radius from the center to the point of tangency, we are going to get a 90-degree angle. Okay? So that means if I look at angle ST and let's say out to L, this is going to always be 90 degrees. From the radius to the point of tangency, we're going to form a 90 degree, or they're going to be two perpendicular lines. All right, so let's take a look at how we can apply that. The first one we see, we have JL is the radius of circle J. And we need to decide whether or not KL is actually going to be tangent to the circle. Is this tangent? And it says to justify our answer. So how do we go about doing that? We need to determine if that is a right triangle. If it is a right triangle, then we need the Pythagorean theorem to hold true. So we're going to use the Pythagorean theorem where we have, keep in mind our hypotenuse is this right here. KJ is the hypotenuse. JL and LK are the legs. So my one leg is 15. So 15 squared plus the other leg, 8 squared, has to equal the hypotenuse. Now, KM is 9. 9 is not the whole side length. So this is just 9. So how do I figure out what MJ is going to be? Well, we need to keep in mind here, if JL is the radius, isn't JM also the radius? And if they are both the radius, and this one is 8, then this measurement is 8. So the leg squared plus the leg squared equals the whole hypotenuse squared. So basically what we're looking at is taking 9 plus 8, and we're going to square that. So really we're testing 15 squared plus 8 squared. Does that in fact equal 17 squared? Well, 15 squared is 225, 8 squared is 64, and 17 squared is 289. When I add these two, 225 and 64, I get 289, so it does equal. Since these two values are equal, this is a right triangle. If these two values did not equal each other, then I would not have a right triangle, which means that KL cannot be the tangent line. So this is KL, and so we would end up saying yes, KL is the tangent. Okay. All right, let's continue on with another example. If I look here, I see I have RS right here is the tangent line to circle Q, and it's tangent right at this point R, and we need to find the value of Y. Okay, so first of all, let's identify what is Y. Y is actually the diameter. And so the diameter is not what we need. We actually need the radius. We need the radius and that tangent line. That's what forms the 90 degrees. So this here is half of y, or if we want, we could actually refer to this as x. I'm going to find what the radius is, And then 2 of these would equal what my value for y is. So, okay, let's set this up. X and 16 are my legs. 20 is the hypotenuse. So I have x squared plus 16 squared equals 20 squared. And that's going to give me x squared plus 256 equals 400. I'm going to subtract 256 from both sides, and I end up with 144. I need to take the square root, and I find out that x is equal to 12. Now keep in mind, this is not my final answer. The radius is 12. I need to figure out the diameters. We always need to make sure we see what we're being asked. And so therefore y is equal to 2 of the x's, so y has to equal 24. All right, let's take a look at another example. We are told that JH is tangent to circle G. It's tangent right here at J, which means this is going to form a right triangle, or right angle, to make the right triangle. We need to figure out the value of x. Notice we are looking for what is x. We're trying to find the radius. So again, we're going to use Pythagorean theorem to do that. This side and this side, G, J, and JH are the legs. So, okay, I have x squared plus 12 squared is equal to, and my hypotenuse, the whole length of the side is whatever x is plus 8. So this is x plus 8, and we're going to square that whole thing. So, all right, so now I've got to, so this stays x squared. 12 squared is 144. And now I need to work this problem here. I've got x plus 8 squared. Keep in mind when I square this, I am going to do x plus 8 times x plus 8. If you forget the shortcut, we're going to work it out the long way. Think about foiling. X times x gives me x squared. X times 8 gives me 8x. 8 times x gives me 8x. And 8 times 8 gives me 64. I'm going to simplify what's going on in here. And this is equal to x squared plus 16x plus 64. Notice, do not fall into the trap of squaring the x and then squaring the 8. That is not going to work out. The shortcut for this is square the front, the x squared, square the back, that's where I get 64, but then take this number and double it. 8 times x and then double it. 8x times 2 is 16x, if that helps. All right, now I'm going to solve for x. The first thing I'm going to do is subtract this x squared, and we're going to notice those x squared terms are going to drop out. I now have 144 equals 16x plus 64. I'm going to subtract 64 from both sides, and I have 80 equals 16x. I'm going to divide each side by 16, and we find that x is equal to a value of 5. Okay. All right. The next thing we're going to look at is if two segments from the same exterior point are tangent to a circle, then they are congruent. So I have point B, and from point B, I can draw a tangent coming this way and hitting it right at point A. I also, from B, can draw a segment and come and hit and be tangent to the circle right at point C. When that happens, these two segments are congruent. AB would equal BC. So with that in mind, let's take a look at this problem here. We have this circle. We have two tangents. We're going to, given that both of these are tangents to circle D, and we need to find the value of x. In order to do that, since we know that they're both tangent, those two are congruent. So I'm going to set up x plus 15 is equal to 2x minus 5. I'm going to solve by subtracting x from both sides. I now have 15 is equal to x minus 5. Add 5 to both sides, and I find that x is equal to 20. All right, and the very last thing we have, we looked the other day at how a circle can circumscribe a polygon. Well, a polygon can also circumscribe a circle. When this happens, when a polygon circumscribes a circle, the sides of the polygon are tangents to the circle. These are examples of circumscribed polygons. We have the triangle circumscribing the circle. We have a quadrilateral. We have a hexagon. This is not what we mean by, notice that we've got all of these seem to be touching in a particular point on the circle, okay? These ones here, the circle, these are not having anything with tangent, so those would not be good examples. These are what we're looking at. All right, so what do I do with that? Say I want to find the perimeter of the triangle, and all the sides are tangent to the circle. We know that the triangle is circumscribing the circle. So where do I go? I know that this whole length is 23. I know this whole length is 22.7, but I really don't know much about this. What I do know is that there are some points of tangencies. Okay? And so let's start over on this one here. If this length here is 14, then this length here must also be 14. So we've got that one. Now where do we go from here? Well, I am given a little clue that the whole thing is 23. If this section is 14, I can get this piece by taking 23 minus 14. And when I take 23 and I subtract 14, I'm going to get a value of 9. So that means that this piece is 9. Now again, because I've got 1 point and I'm going to hit 2 different points of tangency, these two are congruent. So this little piece here is 9. Well, I'm getting closer, but I still need to know something about what's going on over here. Again, I know the whole thing is 22.7. I know this section is 9, so I'm going to take that away to see what is left. And I'm left with 13.7. So this piece is 13.7. If this side is 13.7, then this side over here is also 13.7. Now that I have all the pieces, I know that I have 14, 13.7, 13.7, 9, 9, and 14. Now I can go ahead and add and find the perimeter. I can add all of these up. I could just kind of shortcut it and say this is 23. I'm going to add that to, I knew this whole length was 22.7. And then when I look at this, I could add the 14 and the 13.7. And I'm going to find, all said and done, when I add everything together, I end up with 73.4 units. No unit of measurement was given, so I'm not going to include it. Now, if I was given feet or yards or any kind of measurement, I would need to make sure I include that with my answer. But that is not the case here. All right, if you have any questions, please don't hesitate to ask. Have a wonderful day.